Looking at 8.5 now, we're going to start graphing rational functions. Okay? So again, the two main things we need to look at with rational functions is where our vertical asymptote is and where our horizontal asymptote is. Okay? We talked about this a little bit when we were looking at our vertical asymptotes before. Remember, we cannot divide by 0, right? If I divide by 0, I break all the rules of math. So my vertical asymptote, where that big fence is where the bottom equals 0. Okay, so this b of x is just our denominator. Oh, hold on. Draw with touch, that's what I do. Okay. I think vertical asymptotes are actually a little bit easier. It's a lot with factoring still, things we've already done. The weird ones are our horizontal asymptotes. Right? The degree, there are 3 cases. If the degree is greater than the degree of the denominator, so a of x is our numerator. I don't know why it keeps jumping. If the degree of a of x is greater than the degree of b of x, there is no horizontal asymptote. If the degree is less than the degree of the denominator, then it is y equals 0. And if they are the same, then it is the leading coefficient divided by the leading coefficient. All of this comes from dividing the two things, right? If it's bigger, it does not give you a straight line. It'll give you something else, and we will never see this first case, so we don't have to worry about that much. If our first number is smaller than what we're dividing by, right, it doesn't go in any times. It's 0 times. And if they're equal, then I am dividing. Okay? So we're going to go through the steps. It's a lot easier if we just do these steps. So step 1, what we're always going to do is our horizontal asymptotes first. The degree equals 0. Right. Here, it's x to the 1. Okay, so the degree equals 1. So for my horizontal asymptote, the degree of my numerator is less than the degree of the denominator. And again, if I look back up here, what does that tell us? If the degree of the first is less than the degree of the second, then it's y equals 0.
That's right.
So at y equals 0, which is just straight down the y-axis, or sorry, the x-axis, that's my horizontal asymptote. Step 2. I underlined it. Then we do our vertical asymptotes. Whatever the denominator, right? We have to set our denominator equal to 0. So x equals 0. This one's nice and easy. There's nothing else to solve. So that's our vertical asymptote. Okay, and there's x equals 0. Step 3. Our last step is, well, I have these asymptotes, I just don't know where my graph actually is. Is it increasing, decreasing? So we're going to find 4 points. 2 left and 2 right of your vertical asymptote. Okay, that's kind of the easiest thing to do. So here is x equals 0 is my vertical asymptote. So I have to choose 2 numbers over here and 2 numbers over here and just plug them in. So let's choose negative 3 or negative 4. So f of negative 4 equals 1 over negative 4. Right? Which equals negative 1/4. If you need to approximate it to a decimal, to negative 0.25, that's fine. You can just use like the calculator, right? If I do 1 divided by 4, gives me 0.25, or control enter on the TI Inspires. Okay. So that's negative 4 and negative 1/4, so it's right here. Then let's do like f of negative 1, usually pretty close to the the vertical asymptote is a good idea. So that's 1 over negative 1, which equals 1 divided by negative 1 is just negative 1. So at negative 1, it's at negative 1. Let's go to the right. Those are the 2 to the left. So let's do the 2 numbers to the right. So f of 1. 1 divided by 1 is just 1. And I'll put it over here. F of, I'm going to choose 4 next. F of 4 equals 1 over 4. Which is 0.25. Sorry, I ran out of room. Okay, so at least 4 points. If you want to find more, feel free. Okay. And then I'm following, I can see that this is going to be under here, so I'm kind of thinking about how I'm going to get close to those asymptotes while still going through the points I found. Okay, and there is our graph of 1 over x. All right, let's look at example 2. F of x equals x over x plus 2. Step 1. So this has a degree of 1. Right, remember your degree is that exponent. This has a degree of 1. So my degrees here are equal. I don't know why I spelled out denominator. You can abbreviate it if you'd like. So when they are equal, if you look back up, it says y equals the leading coefficient over the leading coefficient. My leading coefficient of my numerator, there's just a 1 in front of that x. My leading coefficient of my denominator, again, there's just a 1 in front of that x, and 1 divided by 1 equals 1. So y equals 1 is my horizontal asymptote. that's it. Those are really the two examples, right? These two where it's just less than or it's equal that we're going to see. Step 2. Vertical asymptotes. I take my denominator. Okay. Well, this one I do have to solve. I'm not done. I'm going to subtract 2. X equals negative 2. This is where x is negative 2. So I'm going to draw that line. Step 3. 4 points. So I'll go to the left, and I just choose any number over here. Let's choose negative 5. It doesn't matter, right? As long as it's to the left of your vertical asymptote. So I'm plugging it in. So I have x, which is negative 5, over negative 5 plus 2. Which equals negative 5 over negative 3. Right. Okay, which equals about 1.7 or 6.7, right? If I do negative 5 divided by negative 3, right, 1.7. My next point, let's do negative 3. That's negative 3 over that equals negative 3 over negative 3 plus 2 is negative 1, which equals 3. So at negative 5, I have 1 and then 0.7 more, so about there. And at negative 3, I have about 3. And then I could do f of negative 1. Which equals negative 1 over, well, negative 1 plus 2 is positive 1, which equals negative 1. And let's do 0. 0 is a nice easy number. Which equals 0 over 2, which is 0. Okay, so these points are in this corner over here, so I know it's going to kind of follow along with that corner. These points are down here, so I know it's going to kind of follow along in this corner. Okay? And there's x over x plus 2. Okay, let's go ahead and turn the page. We have a lot of examples. Okay, looking at example 3. We have 4x plus 2 over x minus 1. So again, same type of thing for step 1. The degree equals 1 because it has a 1 here and a 1 here. So for my horizontal asymptote, y equals, there's a 4 over 1, which equals 4, right? Because these are the same. Perfect. Vertical, oh, and let's graph that. Y equals 4. horizontal asymptotes. I take my numerator, x minus 1 equals 0. X equals 1. Here's x equals 1. Step 3, 4 points. Let's do f of negative 1 equals 4 times negative 1 plus 2 over negative 1 minus 1. Negative 4 times negative 1 is negative 4, plus 2 is negative 2. Negative 1 minus 1 is negative 2, and that equals 1. So at negative 1, I'm at 1. And let's do 0. Always an easy 4 times 0 plus 2 over 0 minus 1. 4 times 0 is 0 plus 2 is 2. Negative 1. 2 divided by negative 1 is negative 2. So at 0, I'm at negative 2. On the other side, let's do 2. Four times 2 is 8, plus 2 is 10. 2 minus 1 is 1. Which equals 10. So at 10, it's all the way up here. Or sorry, at 2, it's all the way up here at this 10, or somewhere up there. It's off my graph. That's okay. I know it's going to be shooting straight up at 2. And then let's think about f of 3. I'll do it over here. So it's 4 times 3 plus 2 over 3 minus 1. 12 plus 2 is 16. 3 minus 1 is 8. Sorry, 3 minus 1 is 2. 16 divided by 2 is 8. I want to find one more point. Let's find 6. So it's at least on our graph. 24, that's 26 over 5, which does simplify to 5.2. I did those kind of quick, just so we did have a point on the graph. So at 6, it's at 5.2 here. So it's a wider arc there, even though they're still getting close. Okay? We're going to do one more example. I'm going to actually skip example 4, and I want to jump down to example 5. So first we're going to do our horizontal asymptotes. Degree equals 0. Degree equals 2. Not the same. So therefore, y equals 0. Okay? It's always 0 if they're not equal. Vertical. So I want x squared plus 3x minus 4 to be 0. Well, in order to solve this, I need to factor it. So I'm going to have x, let's do our little thing here. I'm adding the 3, multiplying a negative 4, that's 4 and negative 1. X plus 4, x minus 1. So that means x plus 4 equals 0, x minus 1 equals 0. So we have negative 4 and 1. For my 4 points here, when I have 2 asymptotes, I need some in each one. I'm going to do 1 point on this side. I'm going to do 2 points in the middle and 1 point over here. So I'm going to choose negative 5. And for this, feel free to type it in a calculator. Right, on the top numerator, we obviously have 5. Negative 5 squared is 25. Minus 15. Minus 5/6. Okay. So it's positive. Almost at 1. Nice and easy. Okay, I want to choose 2 points in between. So 0 is always easy. So I'll start there. F over 0 squared plus 3 times 0 minus 4, which equals 5 over negative 4, which is negative 1.25 or negative 5/4. So at 0, we're at a little more than 1. And let's choose negative 2. Let's see what's happening there. Okay, negative 2 squared is 4. 3 times negative 2 is negative 6. 4 minus 6 is negative 2. Minus 4 is negative 6. So it's just a little bit, it's negative and just a little bit before 1. Okay. And then let's do the point f of 2. 2 squared plus 3 times 2 minus 4. 2 squared is 4 plus 6 minus 4, and so that would give us 6. Okay. So I'm going to assume this side, right, it's on top here going like that. This side is also doing that. I'm going to assume that's doing something like that. Okay, a lot of times that middle piece is going up and then down. Okay. Some of this is assumptions, right? If you really want to fill in the rest of your points, feel free. You'll get a better idea. I'm not going to be too worried. As long as you have your horizontal, your vertical, and then 4 points, I will say you have full points. Okay? And everything kind of goes together, you will get credit for it. All right? Sorry for the longer video. I will see you guys tomorrow.